Notes, we're going to be talking about the properties of equality and properties of congruence, and we will start doing proofs. And so some of the problems will ask you just to identify which property they are illustrating, and some of them we will have to do a proof and use these properties in a proof. There are a couple of things that I want us to add into our notes here, and we have properties of equality, properties of congruence. Sometimes we have to write property of equality or property of congruence after we name the property. Now, things like addition, subtraction, multiplication, division, those only have a property of equality. So if you don't put property of equality after those, it's not that big of a deal. As far as reflexive, symmetric, and transitive, as you can see, those are highlighted. Those have a property of equality and a property of congruence, and you'll have to write the correct thing at the end. As you can see in these statements, they have equal signs. So these are the reflexive property of equality. So we usually put reflexive prop equality. I guess they already put property, you just have to add equality at the end. Symmetric property of equality, so I should be adding of equal sign. Symmetric property of equality and transitive property of equality. Now the addition property is just adding the same thing to both sides like you do when you're solving algebra problems. They can add a segment to both sides, they can add an angle to both sides, or the measure of a segment or the measure of an angle. Subtraction property, you could subtract a number, you could subtract the length of a segment, the measure of an angle. Multiplication property, you can multiply both sides by the same thing. Division property, dividing both sides by the same thing. The reflexive property is when you say that something is equal to itself. It seems silly right now, but you will see that we are going to use that in our proofs quite a bit actually. The symmetric property essentially changes the sides that the letters are, as far as where they are with the equal sign. This says A equals B, and then they flipped the order to have B equals A. You'll see that sometimes in our proof, we need to end our proof with it looking just like what we're supposed to prove, and sometimes that means we have to switch sides of the equal sign, and then you'll see the symmetric property of equality for that. The transitive property of equality is when you know, like here, it says A is equal to B and B is equal to C, then A is equal to C. So it's kind of linking these pieces of information up differently. I like to call this taking out the middleman. See how B is used twice. We took B out and linked together A and C. And so transitive property, it takes 3 pieces of information to have this transitive property happen. Notice we've got A equals B, that's 1, B equals C, that's 2, and A equals C is the 3rd piece. Symmetric only requires 2 pieces, and reflexive only requires 1. So sometimes that helps me to identify them on the problems where they're just like, what property is this? The substitution property says that if A is equal to B, then B can replace A in any expression. So usually a substitution is replacing a small part of an expression or an equation with something that it is equal to. So we could replace A with B in an equation. Transitive property, the way it's different than substitution, because it is a lot like substitution. It's kind of like if we know A is equal to B, we could substitute B with the letter A to get A equals C. So sometimes these are interchangeable, but transitive property has to be an entire side of the equation that is being replaced instead of one small piece inside of an equation. So we'll practice this and you'll see the difference. Reflexive property, properties of congruence are on this page, so properties of congruence. And so you have to say reflexive property of congruence, symmetric property of congruence, and transitive property of congruence. You're going to have to add that onto the end if you write this as a reason, because you need to show that you understand that it's different from the reflexive property of equality or the symmetric property of equality. We have reflexive property of congruence. And so that's when the items are congruent. And we should have bars over this. Remember, AB with the bar and the congruent symbol. If you have that congruent symbol, you've got to have the bar over the top. So let me fix these on your paper with me. We have to have the bars over the top when we have the congruent sign in the middle. So segment AB, congruent to segment AB, reflexive property. Angle A, congruent to angle A, reflexive property of congruence. Again, be sure you put of congruence, or at least reflexive, I keep saying that wrong, reflexive prop congruent symbol is how I abbreviate that in a proof. We're going to use that quite a bit, especially when we start proving triangles congruent. Symmetric property of congruence, again, if you're just flipping the sides of the congruent symbol there, if you wanted to write it a certain way to make it match your proof statement. And transitive property of congruence, we are going to use this quite a bit. If you ever have a congruent sign in your expression, or in your, instead of an equal sign, and you feel like the answer is substitution, there is no substitution property of congruence. So if you're feeling like that, you need to go with transitive property of congruence. So it's kind of, a lot of the time when you feel like it's substitution, check the symbol. If it's an equal sign, you can put substitution, but if it is a congruent sign, you have to put transitive property of congruence. So let's practice some of these. Here it says proof. A proof is a logical argument that shows a statement is true. And a theorem, unlike a postulate, is a statement that must be proven to be true. So here are some of the questions where they just give you a very clear, here, what property is being illustrated right here. It's easier than if they are in a proof, just kind of by themselves. It's more clear to tell. We see the congruent symbol here, so it has to be one of our properties of congruence. There's only 3 of those: symmetric, reflexive, and transitive. Here, what we're doing, we're taking out that middle man. T is repeated. We're linking together R and P instead. This is transitive property of congruence. Don't forget to add that of congruence at the end there, because it is a congruence property. The second one here, what they did was NK was on the left and now it's on the right. BD was on the right, now it's on the left. So they switched sides. This is symmetric property of congruence. A lot of people mix up symmetric and reflexive. To be reflexive, it would have to be something like AB congruent to AB, the exact same name on both sides. You could have it like this. This is the one people think is symmetric, but it is reflexive. AB and BA are the same exact segment. Since they are the same exact segment, they are reflexive property of congruence. Versus symmetric, they are different segments that are congruent to each other, and you're just switching the sides that it was written on. Versus here again, same segment on both sides is reflexive property. These are both reflexive property. So we're going to start with some algebra proofs as we start to do proofs, so that you can link it to something that you, some prior knowledge that you have. So as we do an algebra proof, the equation is given to us. Given is what you put for anything that they tell you is true, but prove or proven is never an answer. So don't end this proof with writing the word prove or proven. It will never be an answer. The algebra equation here, as we're solving it, they've done the steps for us, so we have to go with their steps and we have to put what they are doing. Sometimes we'll have you do the steps and put what you're doing, and sometimes we'll have you fill in bits and pieces like how this one has some missing information. So from step A to step B, we have to say over here, what did they do? So from first thing, they gave us the equation, that's here. From A to B, they multiplied both sides by 2. They're wanting to get rid of their fractions. That is multiplication. Property of equality. Now, property of equality here, I'm not going to count off if you don't have it for multiplication, addition, subtraction, that sort of thing, because they only have the property of equality. Again, it's the ones that have the property of congruence that you have to be extra careful of. Now, from B to C, some people mess this up. Some people put multiplication because they are multiplying the 2 with the stuff here and the 2 with the 8 to get that. But multiplication is when you are multiplying both sides of the equation by the same number, and we already have done that in step B. Step C is a matter of simplification, and we have to think of what are we doing to simplify this. To simplify from B to C, we have distributed the 2 through the parentheses and distributed the 2 to the 8 here, really simplified on that side. So we're going to put distribution here, because that is a distribution property of equality is correct, or again, just distribution is fine. Now, from C to D, we have to think about what happened here. They have subtracted 3 to get the negative 4x alone. So they have done subtraction property of equality. And then from D to E, they have divided by a negative 4. So that's just division property of equality. So just an algebra proof there. Here is another algebra proof. Again, what we're given is the equation. And again, proven or proven is never a reason, so do not put that as a reason. From A to B, they have wanted to get rid of those fractions. They multiplied both sides by 2, multiplication. Property of equality there. And then from B to C, we're having to fill in C. So they told us what they did here. They distributed. So we're going to have to distribute on our left side here. So 2 times 4 is 8. 2 times negative 1/2 is negative 1x there. And then 2 times 7 over 2 is 7 minus 2x, just distributing to both pieces. Now we have to look from C to D and see what they have done. They have subtracted 7 from both sides, so it's subtraction. Property of equality there. And then from D to E, they're saying that they must have added x. So we're going to go with 1 equals negative x would be the answer there, because adding x to negative 2x is negative x. Now from E to F, we have, you could say this either as multiply by negative 1 or as divide by negative 1. So you could have multiplication or division. And then for G, they have switched sides. Do you see how they needed it to look like this prove statement at the end? So they're having to change around which side has the negative 1 and which side has the x. That is the symmetric. And symmetric property has equality and congruence, so we do have to clarify here that it's an equal sign, so it's symmetric property of equality. So that's one time where that's sort of coming into these proofs. Here is one of our first